Good morning. In this class, we will study about physical equilibria and phase rule. What is equilibrium? What is equilibrium? For example, water. I have taken water and heating. On heating, it is converted into vapor. Water is converted into vapor. Water in equilibrium with vapor. So, it is phase equilibrium. It is a system in equilibrium. It is a system in equilibrium. There are two phases. You see, there are two phases, phase equilibria. So, this is a system, equilibrium system. There are two phases, vapor phase and liquid phase are in equilibrium with each other. There are two phases. Okay. Now, see, what is phase rule? Phase rule gives the quantitative study of the equilibrium system. Phase rule is the study of quantitative study of equilibrium system. Quantitative study of equilibrium system. JW gives thermodynamically derived the phase rule, the mathematical form of phase rule. He derived the mathematical form of phase rule by using thermodynamical method. Okay, F equal to C minus P plus 2. Now there are three important terms in this phase rule. There are three important terms. They are degrees of freedom, components, number of components and phases. Now we will see one by one. First we will see what is the phase. You are seeing a phase, liquid phase, vapor phase. A phase is a homogeneous. It is homogeneous, very well homogeneous. A phase is a homogeneous and physically distinct part of the equilibrium system. Okay, a phase is defined as a homogeneous and physically distinct part of a system bounded by a surface. Bounded by a surface. Okay, it has a bounded by a surface and mechanically separable. They can be, the vapor can be separated from liquid. Okay. For example, let us see a few examples you will easily understand. For example, nitrogen oxygen gaseous mixture. For example, atmospheric gas. It will form a gaseous mixture, gaseous homogeneous mixture. Therefore, only one phase, gas phase. Therefore, it is one phase. Okay. In another example, carbon tetrachloride mixed with water. Carbon tetrachloride is heavier than, is having more density than water. Therefore, CCl4 will be at the bottom layer, and therefore there are two phases. Both are liquid phases, but they are physically distinct part. Therefore, there are two phases. Suppose if you mix immiscible liquids, they don't mix with each other. Miscible liquids, they mix with each other. For example, alcohol and water, it will be one phase, homogeneous, one phase, one phase. Okay. And this is, let us take heterogeneous chemical equilibrium. This is heterogeneous physical equilibrium. Liquid phase, vapor phase, heterogeneous. Homogeneous means all of them are in the same phase. All of them are the reactants and products are in the same phase. Here you see calcium carbonate in a closed vessel. On heating gives calcium oxide and plus CO2 gas. Therefore, there are two phases. Remember, there are two phases. One is gaseous phase, another is solid phase. Therefore, there are two phases. Now, we have seen what is a phase. Okay, in the phase rule. Now, we will see the number of components. What are components? Components are defined as the smallest number of constituents to express the composition of an equilibrium system. Okay, for example, sugar solution is obtained by mixing sugar and water. Okay, therefore there are two components. Are mixed to know the concentration or the composition. Composition means what are the constituents present in the solution. What are the constituents present in the mixture. There are two constituents. Okay, and in the case of ice, water, vapor equilibrium. Ice you have water and also vapors. There are three phases, but only one component is enough to express the composition. Only one component system, water for example. Sulfur, for example, sulfur exists in monoclinic sulfur, rhombic sulfur, liquid state and vapor state. There are four phases, but only one component. If you take only pure sulfur. Okay. Next we will see what are degrees of freedom. That is very important. Using now, if you know the number of components and phases, number of phases from the above, you can calculate the degrees of freedom. You can calculate the degree of freedom. What is the degree of freedom? It is defined as the number of independent variables. Number of independent variables to define the system completely. What are independent variables? Such as the temperature, pressure, concentration, that is the composition, what are the constituents, to define the system completely. So it is defined as the number of independent variables to define the system completely. For example, let us consider a gaseous system. Let us consider a pure gas, okay, no mixture, pure gas, nitrogen gas or oxygen, pure gas. Now, in order to define a system, we need two variables, two independent variables, pressure or temperature. If you know pressure, temperature, volume, but if you know pressure, temperature, you can calculate the volume using the ideal gas equation, Pv is equal to nRT. Therefore, there are two variables are required to define the system completely. Okay, or it may be pressure volume or temperature volume, any two variables. The third variable can be calculated. Therefore, there are two only variables. You can also use this formula. For example, number of components, pure gas 1. Okay, number of phases 1. Therefore, 1 minus 1 2. Therefore the degree of freedom is 2. You can use either your knowledge or use the formula to calculate the degrees of freedom. Okay, now at equilibrium system, vapor, liquid, vapor, equilibrium system, if you know the temperature, the vapor pressure is known from the clock table. If you fix the temperature, similarly you can use the formula number of component 1, number of phase 2 and plus 2, then you will get 1. Okay, so the degree of freedom for this liquid, water, vapor, equilibrium is 1. At freezing point of water, for example, at freezing point of water, there exists ice, water, vapor. There are three phases. And the degree of freedom, if you substitute in this formula, number of components 1, phases 3, therefore F equal to 0. The degree of freedom is 0. Okay. Always the number of phases increases. The smaller will be, the greater the number of phases, smaller will be the degree of freedom. Remember, greater the number of phases, the smaller the degree of freedom. Okay, now if F equal to 0, if the degree of freedom is equal to 0 for an equilibrium system, then it is called invariant system. If the degree of freedom of a system, equilibrium system, is equal to 2, it is called a bivariant. If F equal to 1, the degree of freedom is equal to 1, then it is called a monovariant. Now, greater the number of components, this is very important. What is the effect of number of components on degree of freedom? What is the effect of number of phases on the degree of freedom? Greater the components, greater will be the degree of freedom, because composition will be there. So you will need to define the concentration of each constituent, each component. So greater the components, greater the degrees of freedom. Similarly, whereas on the other hand, greater the number of phases, for example, smaller is the degree of freedom. Okay, so based on the fundamentals, there will be several questions asked in competitive examination. Please understand, please write down first and understand, and you will be able to answer all the questions. Okay, thank you very much for watching.